UK Power Networks, how we're using a quadrature booster to improve the network. The number of generators connecting to the electricity network continues to grow. To accommodate them, sometimes the network needs to be upgraded. That can be costly. UK Power Networks is looking for ways to increase capacity, but at the lowest possible cost. Wissington in Norfolk was an area with a capacity problem. A factory there wasn't able to maximise the generation capacity of its CHP plant because of a constraint on two parallel circuits feeding the factory. The line from Wissington to Downham Market is shorter than the other. As a result, it got overloaded before the generator was at its highest output.
Electricity flows through the path of least impedance, so what we have is that we have one of the lines actually getting closer to its operational limits in terms of capacity a lot quicker than the other lines.
One way of increasing capacity on lines like those at Wissington is by using a quadrature booster, or quad booster. It's basically a special type of transformer, and it works by balancing the power on parallel electricity circuits. Circuits are imbalanced when one line is carrying more electricity than the other. The quad booster sits on the Downham Market line and pushes electricity from it to the Northwold line. This balances the network and results in more capacity.
A simple way of describing what the quad booster is doing in this instance is to think that the quad booster is pushing power from the heavily loaded circuit onto the less loaded circuit, the technical term for which is bucking.
As we said, our quad booster is at a factory in Wissington, and the control system is in a local substation hardwired to the quad booster. The control system automatically manages the power flows. It can be operated remotely from the UK Power Networks Control Centre in Ipswich using the SCADA system, that's supervisory control and data acquisition. The quad booster is making the existing network more efficient, and it's hoped will prevent the need for the upgrading of the Wissington distribution network.
It has been thought as an expensive solution. I think we have proven that given a specific application, when compared with a traditional network reinforcement, it can be a cost-effective solution for distribution networks.
Quad boosters aren't new. They've been used on the high-voltage transmission grid in the UK since the 1960s, at 275 kV or 400 kV. However, we understand this is the first time in the world one has been connected to a distribution network at 33 kV. So you may be wondering, why hasn't the quad booster been used on a distribution network before? Mainly it was because one didn't exist that could operate at lower voltages. Developing one has been a significant engineering challenge. It's cost £1.6 million, but we believe it will prove to be good value. Installing a new 33 kV overhead line to solve the problem at Wissington would have cost £3 million, and an underground cable would have cost £6 million.
The quad booster was best value in this instance, as the traditional means of providing additional capacity for the site would be to install either an underground cable or an overhead line, both of which would take longer and cost more.
As part of the flexible plug-and-play programme, we'll be carrying out a full cost-benefit analysis. It will compare the price of the quad booster and its running costs against future upgrading costs for the network. At UK Power Networks, we've promised that all the lessons learned from the installation of the quad booster at Wissington will be shared with the electricity distribution industry and other interested parties so that the knowledge spreads as widely as possible. UK Power Networks, leading the journey to improve your network.